Hi, I'm Rob Price, and I'm talking to some inspirational leaders of some of the leading AI and Gen AI businesses in the world. Welcome to Futurise.
Hi Rob, thanks for having me. I'm Tushar, co-founder of Ecomedic. So right now what we're doing is like if you look at from a healthcare industry, it has more emissions than the aviation, shipping, or the automotive industry. So it's 2x the aviation industry and almost 55% more than the automotive industry. And and there is a lot of regulations that have come up in the EU as well as from NHS that is asking to start making changes to the entire supply chain, which is like how can we first measure the emissions and then start reducing them. And the reason is like if you look at like the emissions from hospitals and healthcare institutions, it has a negative effect on like human health. And some of the studies that have been done in the US, there is some like data around like 188,000 people getting affected every year due to the toxins and the waste that is coming out of the healthcare industry. Ecomedic is focused about like how can we first start measuring the emissions and then how can we reduce the emissions. And with the measure part, what we are doing is like we are doing it differently compared to, let's say, other sort of like emission measurement tools. What we're doing is life cycle assessment. So we look at like the entire value chain or the supply chain of the medical products and services. So starting from raw material usage to the manufacturing, to the use location, and then what are they incinerated or are they like sent to a landfill? And then we look at energy inputs at different points. And that's why we've created an AI tool around it, which the LLM models have made it possible by using large, vast amounts of data and then making it concise. So this is where we are on our journey right now, working with few hospitals. We are working with few medical suppliers who are supplying to the NHS, and then we are trying to improve the product as we go along.
So tell me a bit about what prompted you to do that. There must have been a time last year when you thought, hey, I kind of really want to make a difference in this space. But there must have been some things that you'd seen before that that had given you that insight and understanding.
Yeah, Rob. So previously I was working on the 3D generative AI, so which was like, how can you generate 3D models through generative AI tech? And so we were exposed to some healthcare use cases, which was like, like can you create a 3D model of a prostrate and guide the surgeons on the AI and create an AI model on top? And some of the questions we would get from time to time is like, if we are moving towards like synthetic content generation, let's say from physical content generation, that how much emissions do you save? So we were like looking at data around like, okay, so if we build like, 10 photos, for example, then it's kind of saving a carbon footprint of a person going from London to Paris and back. And that's when I came across NLC Ventures. It's like a largest healthcare accelerator in Europe. And they mostly work on problems around like, let's say, solving cancer or like, solving some arthritis related diseases. And they do it through medical devices. And the recurrent theme that they're getting is like from the hospitals is like, how sustainable you are. And that's how we kind of came together and started to look into the data like, okay, healthcare has massive amounts of emissions and this needs to be start like getting measured right now. So that's how the idea came into being. And then it was mostly around like, it came in October. And then that was mostly around like interviewing a lot of people from hospitals. And the common theme that we would see was like the sustainability managers, let's say at hospital, they always say that we don't want cost-based accounting. So the way the cost-based accounting works is basically that like if you go to a bar and order a drink, so what will happen is you will just multiply the cost of the drink with an emission factor, and that's how you get the emissions. But that doesn't work for hospitals because if you see the cost of like the medical services continue to rise, and then there is inflation attached to it. So what it will always show is that the emissions are rising, which may not be the case. So which is why they always kept on talking about life cycle assessments and like why those are needed and why those are important to identify the hotspots. And on deep diving further, we found out like it takes 6 to 8 months to do life cycle assessments. And right now it's mostly done by manually by consultants, like big companies. And there's a huge cost factor to it, which like I feel like hospitals who are already constrained with the budget, they can't really afford like thousands of pounds or dollars being spent on life cycle assessments. And then large language models started to come up in sometime last year, and it felt like a lot of the time that is being spent on data collection. Okay, where is your manufacturing facility? What is the manufacturing process? How much does energy is being used by injection molding? All these things is an unstructured data that is out there. And large language model can really bring them together to actually reduce the time, the 75% of the time that is being spent on data collection. So which is why we create a whole AI LCA product around it.
Fantastic. So in terms of thinking about the conversations that you're having, because you're quite early stage, aren't you? I mean, you mentioned October last year in terms of starting this off. So tell us a bit about your journey in terms of establishing that concept and product. And you mentioned you were working with a few hospitals already, which is great at such an early stage. So how's it been in terms of what we're 5, 6 months in now?
Yeah, so initially, like when we started, I just had a simple dashboard, which was like just you add the emissions value to it and it will record. So it's just like a table. And on the back end side of things, it was just mostly Excel sheets. So it was very like you would say bootstrapped way of building the product. So when we took that to in like October timeline to hospitals, they were not that interested in dashboard. It's like, where is the data coming from? Who is going to, and the data was not present per se. And that's how we discovered the problem that we need to probably start creating a in-house research database, which can be used by the LLMs to actually heavyweight lift what is there. So October to November, it was mostly around doing small free pilots. So we would do just free pilots just to learn from the experience. So we did it with Macwell Health. We did a study for them. We had like PHS Hospital in the US showed interest to us. And so on doing these free pilots, we learned like how the LCA is done and what are the like biggest sort of pain points around it. And in December, we started working on the large language model, which was like, okay, let's use Gemini and then just let's, like use the unstructured data and then get it done with. But we like kind of faced a lot of hurdles along the way because if you look at life cycle assessments, it has to be very detailed and has to have very accurate information. And the first roadblock we hit was like, how do we provide a really accurate information that the climate analysts can see and then can verify that this is accurate? And what we were seeing was like, if you ask the energy value, let's say to Gemini or to Cloud, you would always get a random number each time, which was not something that we wanted to do. So we started with the vector database. We toyed around vector database, but we wanted like 95% accuracy. And in February, we started working on like the graph-based LLMs, which has really improved the accuracy of the product.
Fantastic. And I only smile in the sense that I recognize that journey and for that very purpose of, well, in a sense, mitigating the uncertainty and unreliableness of the LLMs by using other tools to find ways of refining to something that's proven. And there is, I mean, that's critical in this space, isn't it? Because as you'll know, there are so many different perspectives around how do you measure and how do you verify and what's right and what's wrong. And I think people have been suffering from that over certainly in different geographies and certainly over the last kind of couple of years. So who do you find is the most interested in that conversation? What type of people within the hospitals or within health environments are very much hooking into your offering, your capability?
That's a great question. So what we have seen is, so there is a lot of interest amongst suppliers that want to supply to the NHS, or so that's one big section of medical suppliers. The second, which could have some overlap with the first group, is that they are coming with more sustainable materials or a more sustainable supply chain. So what they're doing is like they want to do life cycle assessments of of their product versus, let's say, a competitive product. And then they were coming with this whole analysis using our tool that like their product is more carbon efficient compared to the other tools. I think the one thing that has happened in the hospital industry, which you will hear a lot, is like if you remember the old times, like people would have just like, all the things being sterilized in steam water and then being reused every time. But what happened over the last, I would say 20, 30 years is like a lot of the single-use materials was pushed into the supply chain, which was like because for the sake of infection. And that has really led to the carbon emissions in the hospital industry. And what we're seeing is a big debate on how the recyclability or the reusability as inside the process can really help the whole healthcare industry. So there's a lot of process comparison, those kind of pain points that are coming to us. Can you compare this process with that process? And then at an overall level, hospitals want to know what's happening. Let's say if there was a cardiac operation that occurred in the hospital yesterday, then what were the emissions related to that specific clinical pathway? So these are the pain points that we are solving right now.
And in terms of the environments in which you operate, they are environments that are used to a strong regulatory focus, a strong ethical responsibility. I mean, health, life sciences, pharmaceuticals, it's
Yeah.
part of the world that's very clear in terms of needing to adhere to the regulations. Now, of course, we're introducing AI and large language models and generative AI into that mix. Then there's another layer. So how do you think about that, and what kind of questions have your clients ask you about ethics and responsibility in the use of AI in those highly regulated spaces?
Yeah, 100%. That's something that we think about a lot. And so what we're doing is we are applying some guardrails. So that there is a graph-based LLM, then there's the guardrails, and then there is the application layer. So these are the three things that is the core part of our technology and how we can actually always have the ethics in place. But there is a more interesting angle that we are seeing right now, we've learned that's called greenwashing, because everyone thinks or everyone wants to believe that their product is more sustainable, which might or might not be the case. To give you an example, like one of the discussions was our product, like for example, is neither incinerated or sent to a landfill. Which to me is like counterintuitive, because even if you look at humans, for the lack of a better example, either like the end of life is incineration or let's say like a landfill. So every product ends up in either of the two buckets. So what we are trying to do is like there are a lot of life cycle assessment studies out there. So sometimes they will do just cradle to gate, for example, which is like just the use phase, and then they would not consider incineration. We are doing the entire thing, which is cradle to the grave, so that could be a standardized data that everyone can see and compare. And they can always go to a point and check like, okay, you have taken a coal-based power station here, and that's why the emissions are showing higher. Maybe that's not the case. So you can always go back, verify the data, and change it and improve it. But the way we are driving this thing is that every data point is sourced to a public source information, or to a direct supplier information is present there.
And I guess the nature of the solutions that you've been talking about would give full auditability and traceability of any way in which that data is processed and presented to the person using it as well.
100%. And that's how we are looking at it.
So tell me a bit more about the organization then. I mean, it's 6 months old, and I mean, we're in a similar position. So it's that, how do we attract the right kind of people who are going to accelerate the pace with which we can deliver the things that we're trying to do? So how have you grown so far? And what strategies have you got in terms of attracting talent into the organization as you continue to grow?
Yeah. So I've had a background of generative AI previously, and I mean, one thing that I've done is very much like, writing to people on LinkedIn a lot, like, we're working on this thing and making them excited and see like if they want to, if they really believe in the mission. Because I feel like finding AI resources is a big challenge for everyone because big companies wants to have the best AI engineers out there. So some of the things that have worked for us is like, working with let's a professor who was at UCL and then he moved to Aberdeen, University of Aberdeen, but he has a lot of publications across CVPR, ICCB, and building that relationship helped us get to a lot of students where we could have like, direct conversation around like, why we are different, what we are building, and what does that mean to their work that they have done previously in their PhDs. So that has helped us attract some AI talent, and definitely there needs to be incentive, which could be like becoming a bigger part of the company through stock options and things like that.
Excellent. And tell me a bit more about how you develop a culture within your organization as well. And I'm leading towards the ambition of what you want to achieve. So, in a sense, as you give the organization an identity, it's easy to imagine how that works from a passion around impact on the world and thinking about sustainability in the right way through from a health sector point of view. But
Yeah.
where are you trying to take people? Where do you want to go?
Yeah, so our mission, like from a mission point of view, we want to save 100 megatons per year, and that would mean a lot to us in terms of the emissions we are able to reduce in the healthcare industry. So the core, like the culture or the principles on what it is based on is like we want to be obviously be part of the whole supply chain, which is moving towards sustainable products. But there is a financial viability angle as well. So if the solution that we devise or we come up with is expensive, then it has less chances of being adopted in the industry. So we look, so for example, lab coat is made of so many different materials, and then if we change the material, what is the impact on sustainability and what is the impact on the cost at the same time? And the third thing is like health equity. That's what something that we learned from NHS, and they focus a lot, which is like people who are marginalized are always at the receiving end of the emissions and the impact of emissions on their health. So at the part of the culture is mostly about thinking about these three things about sustainability, financial viability, and health equity in all the work that we are doing. That should be part of the product. That should be part of all the conversations that are happening internally as well as externally, and how we can get to our ambition of 100 megatons per year slowly and gradually. Um,
And I think just in finishing off, I mean, the thing that I love about what you've described is for a lot of the kind of past few years, we've talked about the impact of the technology that we use on people and the planet. And actually, what you're using is technology like large language models and AI, for which people might say, oh, well, there's high energy use and that's a worry, but actually to drive innovative impact in a kind of key area of the economy. So in a sense, it's like a scale, isn't it? It's yes, I'm using these technologies, but I'm using it to make a significant positive impact in the way in which we can, well, look after society as a whole through health provision in that sense.
100%. Yeah, I feel like as we become more and more sustainable and have more and more sustainable products in the pipeline, it's going to benefit everyone in the society.
Tushar,
So,
it's been fantastic to talk to you. So many thanks for coming on the podcast. And yeah, it's great to hear. Hopefully you'll get some positive growth on the back of the conversations that I know that you've been having.
yeah, really hoping for it. Thanks so much, Rob, for having me. It was a great discussion.